Hi everyone, this is Mr. Kachinga. In this video, we'll look at linear programming. The area of the focus is finding inequalities on unshaded region R. So, before we proceed, when it comes to unshaded region R, it means getting the opposite. For example, if the answer is greater than, we have to take less than. Okay, I'll demonstrate this when you look at this diagram. So the question reads, write the three inequalities that define the unshaded region R on the X or Y plane. So this is the question. Then on the question, we have the diagram. Okay. So when we look at the question, they want the three inequalities. So first of all, we have to identify those three inequalities. This is R that they are saying. Now, this R, it has corners. We have this corner, we have this, and this. Then inside R, nothing is shaded, as you can see. When identifying the inequalities, always start with the point which is the easiest. Okay, now let's look at this line. You see, when we follow this line like this, when we follow this line, we can observe that it is cutting the x-axis at negative what? 2. This is the x-axis. Now, some of you may not see that. Let me demonstrate on a paper here. So, we have the Cartesian plane like this, okay? So this is the x. Now, as we go at x, here there is negative 2. You see, I have cut it here, and it's shaded this side. You see that? So this is the meaning that I'm saying when you compare the two. So this is x. X is cutted at negative 2, as you can see. Now, for the sake of interest, this part is less than, okay? Since the line is solid, by solid I mean it is not dotted. Remember, solid line is either presented by less than or equal to or greater than and equal to. And dotted line, which is liquid. So liquid, it is either presented by less than without a bar or greater than. Okay. Now, coming back to this, it is solid line. So less than, we put like this. Then this side is greater than. So greater than, it is like this. Now, where is shaded is less than. So we take the opposite. So opposite of where it is not shaded is greater than or equal to this line here. This line. Okay? So inequality number 1, we'll say x is greater than negative 2. Okay, here x is greater than negative 2. It is shaded going this side. We have picked the greater than, which is there. Then number 2, we have to identify inequality number 2. So the inequality number 2, there is this line. Just follow me, this line, okay? When I put a pen like this, okay? Now, we can observe that this is the y-axis and it is cutted here. It is cutted at 1. Let me demonstrate here. So we have the Cartesian plane like this. This is 0, 1 is here, and we cut. This is y, you see? So we have cut y at what? At 1, and it is shaded downwards. So downward is less than, then on top is greater than. Okay, here is less than or equal to, greater than or equal to. Now, since we have shaded on less, as we are going to pick the what? The greater than. That is the meaning. So here, as you can see, it is cutting the y-axis at 1. So here going down is less than or equal to, as we pick the upward, which is greater than. So we say y is greater than or equal to 1. Okay? That is what we do. Then the fading quality. As you can see, there is this line again. This line, the sloping line. When I put a pen like this, okay, then it is shaded this side, this side. Now, this line, whatever line is sloping, it can slope like this. Sometimes it can slope like this. Any direction, okay? As long as the line is bending or sloping, we don't pick the set of inequalities directly, like the way we have done for 1 and 2. For x, we know is just straight. It is cutting at -2. Then for y, it is straight cutting at 1. We pick direct. But for this one, we don't pick direct, okay? That's why when you look at the equation, we have been given points. There is -2, 4 here. -2 is here, then 4 here, okay? This on this corner, since it is in this line. Then here, there is 1, 1 at here. So for this one, since we have been given guided points, we will use this guided points. But if the points were not given, we could have take 2 points that are passing, any 2 points passing in this line. But for that one, it will be demonstrated in example 2. For now, we'll stick to these points, -2, 4 and 1, 1. So these points, they are used to find the gradient. Since remember, the slope of the line, the slope present the gradient. When we find the gradient, we are going to find the equation of the straight line. Then that equation of the straight line will present the inequality. So I'll demonstrate. So as you can see here, I've just picked this point, -2, 4, which is here, 1, 1, which is here. So the reason I'm doing this, I want to find the slope or the gradient of this line. So it doesn't matter. If I wanted, I could have started with 1, 1 to be here and -2, 4 to be that side. Still the gradient will be the same. So this will be x1, this y1, then here x2, then this y2. We all know that the formula for gradient is m is equals to y2 minus y1 over x2 minus x1. This is the formula for gradient. Then we say our m, it is equals to y2. Now y2 is 1. 1 minus y1. So y1, as you can see, it is 4. Then over x2. So x2 is 1 there. So 1 minus x1. So on x1 there is a negative, but we have also this negative. So we'll put it in the bracket. So our m equals 1 minus 4. So 1 minus 4 is -3 over 1. Negative times negative is a positive, but there is 2, so 2 will come. So our m equals to -3 over 1 plus 2 is 3. Then our m finally, 3 into 3 is -1. Since here there is a negative, we are finding the gradient. Now, after finding the gradient, we have to find the equation of the straight line. So we know that when finding the equation of the straight line, we use this formula. Y minus y1 equals to m times x minus x1. Okay. Then we can pick any point here to find the equation of a straight line. We can pick this or we can pick this. Okay. So suppose I pick the first point So on the first point, I pick -2, 4. This is x1, y1. Then we know gradient is equals to -1. We have found the gradient to be -1. Then from here, we start substituting. So y minus y1. Okay, so y1, it is here, which is 4. So 4 equals to m. Our m presenting gradient -1, then times our x. So our x, the way it is, minus x1. As you can see, x1 is -2, so -2 in the bracket. So we say y minus 4 equals -1, then x. This negative by negative is positive. Okay? So from here we say y minus 4 equals, we can multiply -1 times x is -x. -1 times +2 is -2. When you reach this point, you just have to take -4 to the other side. This -4 will go to the other side, so that we remain with y equals -x minus 2 plus a 4. It is negative. When it crosses the equal sign, becomes positive. Then y equals -x. So -2 plus a 4, it is +2. Now, this is the equation of the straight line for this slope. This slope here. This slope here. This slope here. That is the equation. Now, the question now we should ask ourselves is, which symbol are we going to put here? Because for inequalities, we don't use the equal sign. So for the third inequality, as you can see, it is shaded on top. Okay? When you have a line like this, and that line is shaded on top, all the lines on top here is greater than, but inside is what? Less than. Since it is solid, this presented like this, and this is presented like this. You see that? So what we'll do is that since they have shade to the greater than, we'll pick less than. So we'll say y is less than or equal -x plus a 2. Okay? So this one will be our third inequality. So we have to write here. We write that our third inequality is y less than or equal to -x plus a 2. That's so. Okay? So this is our third inequality. So the solving, it becomes just when the line is sloping like this or like that. Otherwise, the line like this is just direct, it's just passing on -2, and this one is direct, passing at 1. But for this one, it's not direct. That's why there were coordinates given, this point and this. Then you find, then always show your work. For the sake of practice, I'll give you example 2 with a line which is sloping. So thank you for watching.